Alright, so it's time to fix yet another dead MacBook. Let's take a look at this board and see what's going on with it. So this is an 820-00875 board. This is in for an A1708 model MacBook. This is one of the MacBooks where it does not have a touch bar, but it has USB-C charge ports. And this is also one of the very few models that I'm pretty sure an engineer at Apple got fired for, because as you can tell, the SSD is user removable, which means that you can actually get your data off of this, and dare I say it, you can upgrade your solid-state drive without having to buy an entirely new machine. So I'm confident that somebody at Apple is being tortured somewhere in their version of Guantanamo Bay for allowing this to get released to the public. So let's just go through. I'm going to find a board view for this beautiful MacBook. We're going to plug in my USB-C amp meter to see how much power it's taking, and then we can get started. So the first thing we're going to do is plug in this USB-C amp meter. This is going to tell me how much power it's using, and the reason I'm interested in seeing how much power it's using is because that will give me an idea of where my problem may lie. Different numbers mean different things. So let's see what this thing does with the USB-C amp meter. Alright, so it takes 20 volts. Now that tells me a couple of things. The first is that pp3v3_g3 hot is present. This chip needs pp3v3_g3 hot to work, and these are the chips that speak to the charger and then request 20 volts. Now, and we also know that those are working. Now, as you can see, it's moving back and forth between 10, 20, 30 milliamps, 10 milliamps, 30 milliamps, 10 milliamps, 30 milliamps, 10 milliamps, 30 milliamps. And it's moving back and forth consistently between that, which means that most likely we have some sort of short circuit, because what that's doing is it's power cycling. It's turning on and then realizing, oh God, I'm turning on when I shouldn't be turning on, turn off. And it's doing that in a repeating loop. So I don't want to necessarily call that boot looping, because the machine is not getting far enough to actually boot. I would call that power cycling. So let's get to work on that. So the first thing I'm going to do is turn on Paul Daniels' excellent multimeter software. I would highly suggest that you all check out Paul Daniels' channel at youtube.com/19PLD73. That's 19PLD73 to watch his content. He makes all sorts of amazing software that helps people in the repair community do the jobs that they need to do. And he has contributed more to the repair community in terms of software that we use for free than just about anybody else that I know. Paul Daniels. Paul Daniels. A great man. Alright, now we're going to look over this board. So the first thing we're going to do is we're going to go through the power rails. So I'm going to find the power rails page on the schematic, and we are going to go through those power rails. Hi told the girl that he's liked for a long time, that he had a crush on her. Let's all hope, let's all wish Hi some good luck. It's not easy to tell the girl of your dreams that you have a crush on her, especially when you're the type of nerd that knows what a PP bus is and whether or not it's G3 hot. I'm telling you, when you're a guy that knows the difference between 12.23 volts and 12.56 volts on your PP bus, it's not easy. It's not easy out there. We should make our own dating app, I swear. Anyway, so let's check this out. Let's see what's going on with all these different rails and figure out which one is causing our power cycling. So the first one on the list is PP bus G3 hot. Now, the way this software works, I right-click the rail. You can't see that because Paul's software puts the mouse in the wrong place because it's, So I right-click, and Flex Board View is automatically going to show me everywhere it shows up on the screen. Then I click, and then I check to see if the voltage is present and also if it's shorted to ground. So I'm going to be doing this, but while I have the desk view go up. So I didn't memorize what all these points are, just so you know. I'm looking at the screen and using the software to help me. So first thing I'm going to do is measure the voltage that I get on my PP bus. Hi is a good dude. Hi has been like taking care of the chat and shilling and just doing all these things and really helping out for a long time. So if anybody deserves some good luck in life, I'd say it's Hi. Alright, we have 13.09 volts on our PP bus. Next up, let's check out PP5ES5. PP5ES5 is going to be on this capacitor right around here. And as can be seen, it goes up and down. Boo. Okay, so we've got a rail that's boot looping, which means that we may have a short on one of the rails related to that. So the first thing I'm going to do is try and figure out where that rail comes from. So that rail comes from U7650. So I want to check out what rails U7650 is responsible for making. So let's do that. So U7650 creates 3 rails. It creates our PP5ES4, it creates our PP3V3S5, and it creates our PP5ES5. So let's see if any of those rails have a short circuit to ground, because if any of them have a short circuit to ground, maybe something's going to be going wrong with this chip. So first thing we're going to do is check out our PP5ES4, or as I like to call it, PP5ES4. Our PP5ES4. We can find that on pin 2 of this chip. Let's see what happens. Pin 2. PP5ES4, 14 kilo ohms to ground. We got no problem there. Next up, we're going to check out PP3V3S5. PP3V3S5. No problem there. Kilo ohms to ground. No short circuit. Next up, let's check out PP3V3S4. We could find PP3V3S4. Let's see. Where can we get that on this board? There's a current sense resistor somewhere over here, I think. Or there's supposed to be a current sense resistor somewhere over here. Here we go. So this pad is where we can check out our PP3V3S4. And we have a 0 ohm short to ground. So, definitely 3VS4 is our problem. So, let's fix PP3V3S4. Let's try and figure out why it's shorted to ground and what could possibly be. Now, it's going to be something over here. Something on anywhere along this line. Any one of these things could be happening. So what we need to do is we're going to inject some voltage into PP3V3S4 and try and figure out what it is that's getting hot. And we may use a thermal camera to help us do this. I got this thermal camera from Union Repair. It works decently well. Does not work $900 worth of well, to be clear. I got this thing for free, which is why I use it. I would not recommend that somebody spend $900 on it. But given that it's free, it's just so happens to be worth putting on the desk and trying out. So let's give that a shot. Before that, I would have probably done something like pour alcohol on the board, or I would have used, let's say, compressed air can and just turned it upside down. By the way, freeze spray is very effective, but freeze spray usually costs more than compressed air. So if you turn a compressed air can upside down, you can use it as freeze spray. Okay, so what we're going to do here is inject some voltage. So let's get to it. So I'm going to get one wire that goes to the ground on my board, and another wire that's going to get soldered to PP3V3S4. So, on my power supply, first thing to do, change the output voltage. You don't want to put 18 volts into the board. I keep it at 18 volts typically because that's the voltage that is used by the older MacBook for the DCN, for the MagSafe. Okay, we're going to just clip this right here. Thank you, Irfan. That's very kind of you. And the next up is we have the hot wire, which is going to go to our PP3V3S4. So, has the landlord fixed the heat yet? No. However, it's 66 degrees in New York right now, so I don't really care. Okay, so a micro pencil is not going to really go to this very well, so we're going to get the other soldering iron to solder this on the board. We are going to, there we go, melts very nicely. And get you right there. This is some nasty, disgusting looking wire, so I'm just going to cut that up a little bit. Admittedly, this is one of my more fun repairs, because we get to blow things up. I've turned this up to 0.8 volts, and it's taking 3 amps already. Wow. So this should be a fairly easy short to detect. I enjoy blowing things up. It's one of the most fun part of the job. Unless it's a CPU. Obviously, if it's a power rail that goes to a buck converter that powers the CPU or the GPU, then you want to lower the voltage so that you don't put too much there. So let's say that a certain power line is 8 volts, and let's say that that power line is used by the CPU buck converter to make 1 volt. Now, let's say that that FET that's going to be doing the switching, the slicing, to turn that 8 volts into 1 volt is shorted, so it's going to pass everything through. Now, if I put 8 volts in there, and that FET is shorted, I just sent 8 volts to my CPU. So it's always good to start with a voltage that's at least half of the CPU voltage of the board if you don't know if that is what's going to the CPU. Here, I know that PP3v3S4 is not going to the CPU. I'm just going to double check before I say that for sure. Yeah, it's not going to the CPU. Fine. And also, I'm only injecting 0.8 volts, so there's no way that I can actually harm anything. That being said, we are going to go to the thermal camera. So this is my thermal camera software. Say hello to Thermal Pepe. Who put Thermal Pepe on the thermal scanner? Yeah, he put Thermal Pepe on the thermal scanner. I love Thermal Pepe. So this is Thermal Pepe. So let's see what we have here. So we're going to put this into the overpriced thermal imager. That is cool, but totally would not recommend anybody spend $900 on, because that's insane. And see what happens. Now, on the right side over here, it tells me what the maximum temperature is. And over here, it's telling me that the maximum temperature is 36 Celsius. That's not really exciting me, so that means that I probably am not in the area with my short. And Thermal Pepe agrees with me. So now we're going to go to the other side of the board and see if there's anything that gets super warm. And nothing gets super warm. Well, the only liquid damage that we have is over here.
Yeah. So that's 42.
Wait, check this out. This may not be internal to the board. Huh.
82.
Okay, so here's one of the questions that I have for this beautiful Chinese software. Now, on the right side of the screen, it's supposed to be telling me what the maximum temperature is on the board, and it says 44. However, when I put my mouse pointer over here, it says maximum temperature 89. So perhaps your short was actually visible, but the software was trolling you.
Mine didn't light up whatsoever.
This cost $900. Good thing I didn't pay that much for it.
Hurts.
All right. So it looks like Thermal Pepe is telling us that our short is right over here. 99 Celsius, 98, yeah, and so it looks like it's something over here. Rather than spending $900 on a thermal camera, it's useful if you spend, let's say, $200 to $400 on a microscope, even if you're just getting the AmpScope SE400, the cheap one that I have in the description. That was my starter microscope.
Just strip mine now. You gotta...
What, this?
Oh, is it the cap or the resistor?
Oh, it's the cap for sure. Look at it.
Oh, fuck me, sideways, yeah.
Yeah, so that cap was gone. So the microscope to me, is a much more valuable tool than the thermal camera, and if I were just starting out, I would definitely rather put my money into a microscope than a thermal camera. And frankly, this is the type of short circuit that you could find even without the thermal camera. I was just expecting this to be difficult because I've had nothing but difficult, miserable touch bars that I've had to go over for the past few days. But had I simply looked this over with the microscope, I would have saved myself the embarrassment of having to use a thermal camera to find that. That's a very easy to find short. A thermal camera would not have been necessary for this. Just some eyes and a brain. Brain is important. Need brain. So we're going to take that off. Bye-bye, Cap. Alright. There's still a little bit of burned capacitor that's stuck to that pad. Let's just try to get that off without knocking into the Wi-Fi chip. I'm going to make a bit of a solder ball and try to drag it off with my solder ball. Alrighty. Alright, let's see if there's any pads left here. Now it's going to be time to switch back to our micro pencil. This is not going to really do the job well. So we're going to go back to the micro pencil. There we go. So see how my iron was able to bring back that pad that I thought was gone? That's the magic of the T30-KN tip. This is my favorite soldering iron tip. I probably should get a fiberglass pen or something like that to scrape the board with, but I have much more fun scraping it with this. I think Paul has one. I always wind up, I don't know, I think he hides it from me. I always wind up just scraping the board with the tip.
I mean, yeah, that's fun.
There we go, brought my pads back. Beautiful. I want to minimize the amount of time I spend heating that Wi-Fi chip, so I am going to not really care if it's not soldered in place perfectly, because it will get soldered in place perfectly when I do the next chip. Succumb to gravity, mofo. Yes. Alright. And so when I put the last piece on there, everything else is going to nicely fall into place. Since I got the flux on there, you'll see. It's going to be beautiful. Okay, go gadget gravity. There you go. Stay down. Sometimes it's a pain in the ass when the chip doesn't want to stay down. Beautiful. That Wi-Fi chip is fine, Beard of Joy. And give that Wi-Fi chip a happy little reflow. What is a good starter microscope? Asked Mark. If you look in the video description, you'll find an Amscope SE400 link, which I think is pretty much the best thing you can get if you're looking for a cheap starter microscope. I got mine for $175. Now this Wi-Fi chip may have some corrosion under it, since that stuff on the bottom had that nasty looking corrosion around it. Which is why we're going to give it a happy little reflow. Once it has a happy little reflow, its balls will all be healthy again, and it'll be making a nice connection to the board. It'll be able to communicate with the board and give the board Wi-Fi. And the board will give the chip a purpose. We're just going to put a little bit of flux here. Soldering flux. Beautiful. That's not a lot of flux, that's a little bit of flux. That's the right amount of flux. Alright, so... Now keep in mind, I'm not reflowing from close up right now. This iron is quite a bit away from the board. I guess you can't really tell depth that well on this camera, but I'm pretty far away. I'm just preheating the area, because I want to use minimal heat when I'm right up on the chip. So I preheat the area to a good amount, and now I'm going to go close to it for the kill. There we go. A little tap. Tap, tap, tap. And now I just wait for it to cool off. Okay, let's see what we get. "20 volts, 600 milliamps. So this is turning on. Great. And since I don't have a heatsink on the CPU, we're just not going to let it stay on for too long. But this is indeed now turning on, which means that we've made progress. So we had a short circuit. We figured out that it was most likely a short circuit because when I started going through the power rails, one of them was going on, off, on, off, on, off. And typically when it's turning on, off, on, off, on, off, the chip is turning itself off because there's a short upstream. Now, the rail that was going up and down was PP5ES5. And that's on the chip that also creates PP3V3S5. So even though PP3V3S5 was fine, PP3V3S4, which is upstream, was not working, and PP3V3S4 comes from PP3V3S5. Since the chip that makes PP3V3S5 and PP5ES5 are the same chip, even though PP3V3S4 was an issue, it was stopping PP5ES5 from working because these rails are essentially created by the same chip. And if the chip realizes that there's a problem on any one of the rails it creates, it just says, I don't want to blow up, I'm going to shut down everything. And we were able to tell that behavior, that what we call power cycling, by using a USB-C amp meter, which is really helpful when diagnosing these products, because I saw, 20 volts, okay, CD3215s are working, PP3V3_G3 hot is there. I saved myself the time and effort of having to make 2 unnecessary measurements and unnecessary steps of troubleshooting, and then I saw, 10 to 30 milliamps going back and forth, 1030, 1030. Now I know, my problem is likely a short circuit because it's not staying still, it's going back and forth, back and forth, back and forth. So it's probably a short circuit on one of those power lines that with a chip that's not going to allow the rail to stay on. So this really does help in terms of really allowing you to tell what is wrong with the product before you actually even put your eyes on it. And that's that. And as always, I hope you learned something. With that, we move on to the next MacBook. Do you have a MacBook that needs to be fixed? We fix MacBooks. Come by our store at 186 First Avenue, located in Manhattan, open 12 to 8 on the weekday, 12 to 4 on the weekends, if you have a MacBook that needs to be fixed. Do you live outside New York City? No problem. Head over to our website and click on the Outside New York mailbox icon, or go to sendyourmacbook.com. That's sendyourmacbook.com to be redirected to the mail and repair instructions page on our website and a form that will tell you how to send your MacBook in. At rossmangroup.com, we offer Mac laptop repair, logic board repairs, clean room data recovery on hard drives, iPhone and iPad data recovery after hard drops or liquid damage, and liquid spill damage repairs on MacBooks. Check us out on Google, where you'll find amazing reviews spanning the past 10 years of our being in business. Whether it's on Google, Yelp, or other platforms, people love the service that we provided for them, and we're more than happy to provide that level of service. You can also check us out on YouTube, where over the past 600 repair videos, we showcase exactly how we do the job we do and show you that we are actually capable of doing it. Unlike many websites that brag about their infinite number of certifications while using photos from stockphoto.com, where they hold a soldering iron from the hot end, we take pride in the work that we do, and we take pride in doing it here, not outsourcing it. Thank you for your business, thank you for watching, and as always, I hope you learned something.